Right, so this video summarizes what you might have missed in Zoom class on December 8th on Tuesday. So mainly today we started a new lesson on average atomic mass and radioactive isotopes. When I was looking at your launches from Monday, yesterday, I noticed that for quite a few of us, from different periods, we're struggling with the idea of what's the difference between an element and an isotope. So in this part, I'm just going to clarify that. Right. So when we're talking about elements, like the elements on the periodic table, right, we have 118 different kinds of elements, right? So for example, here in this image, I have one type of elements, hydrogen and hydrogen, right? So just hydrogen. So both the purple and the green circles represent elements of hydrogen. But when we're talking about isotopes, we're talking about elements that are the same but have slightly different masses. So for example, all of the purple hydrogens have a mass of 1, and all of the green hydrogens have a mass of 2. They both have 1 proton each, right? Because if they are both hydrogen, they both have 1 proton, but their mass or their weights might be a little bit different. And this has to do with the stars colliding into each other to form new elements, and that sometimes creates the same elements or the same number of protons with a different mass or different number of neutrons, right? And the goal of class today was to figure out, okay, if some hydrogens have a mass of 1 and other hydrogens or other isotopes of hydrogens have a mass of 2, how do we end up with this weird average atomic mass number down here where I have a decimal, 1.008, especially since, right, the mass is just protons and neutrons added together. So all of those are whole numbers, right, for protons and neutrons. So how do we end up with a mass that has a decimal at the end? So to do that, we went through this PhET simulation. And let's just do this PhET simulation together, right? So notice that if I just have one isotope, or the purple hydrogen that happens to weigh 1, my average atomic mass is just 1, right? But if I have another isotope that weighs a mass of 2, or exactly 1 of each type, right, I will have an average atomic mass of 1.5, or a number that is directly between the mass of the purple one, or hydrogen 1, and the mass of the green one, or hydrogen 2, right? So if I happen to have a large mass or a large amount of hydrogen 1s in the universe and a tiny amount of hydrogen 2s, the average atomic mass, or the number that shows up down here, is going to be closer to the purple hydrogens that have a mass of 1, right? But if I have lots of hydrogen 2s, but not a lot of purple hydrogen 1s, notice that the average atomic mass is going to shift closer to hydrogen 2's mass. 1.9 is very close to the number 2, right? So average atomic mass refers to how many types of hydrogens exist in the world, right? And the more of that type of hydrogen there are, or the more of that isotope of hydrogen there are, the closer the average atomic mass will be to that number, right? So let's scroll down to this part, right? So below here on this card is the actual average atomic mass of hydrogen, 1.008. So do you think there are more of hydrogens that weigh 1 or more of hydrogens that weigh 2 if the average atomic mass for hydrogen is 1.008? Go ahead and think to yourself and then unpause this video whenever you're ready. Okay, so looking at the average atomic mass, if it's 1.008, right? And if we notice that, hey, if there are more hydrogen 1s than hydrogen 2s, the average atomic mass is going to shift to hydrogen 1, right? So here's the actual number, 1.008. Notice that there are way more hydrogen 1s than there are of the green hydrogen 2s. In fact, there's about 1 in 1,000, right? So here, if our average atomic mass is 1.008, then that means I have way more hydrogen 1s than hydrogen 2s. The easiest way to tell is just matching the number, right? So if the average atomic mass is 1 point something, well, that's closer to 1 or 2. Well, that's closer to 1. So there's going to be more of hydrogen 1. And as you can see here, if we bottled up all of the hydrogens, there are often way more hydrogens that have a mass of 1 than there are of hydrogens that have a mass of 2. And in Nearpod lesson 3.7, we're going to work on how do we calculate the average atomic mass, or this number, right? So you might wonder, why do we care about figuring out the ratios of how many hydrogen 1s and how many hydrogen 2s there are? And that has to do more with how we treat cancer. So in Nearpod lesson 3.8 and 3.9, we're going to talk about isotope stability, right? So notice that hydrogen 1 is a stable isotope or type of hydrogen, meaning that it's not really vibrating, it's just kind of hanging out doing its own thing. And if I add one more neutron to make hydrogen 2, here, hydrogen 2 is also stable, right? It's still just hanging out, doing its own thing. But if I add one more neutron, I have what's called an unstable isotope. This one's kind of vibrating, it's shaking around. And when this is vibrating and it's unstable, it tends to shoot out something called radiation. And there are 3 types of radiation in which we're going to talk about in this class, right? And that's what you're going to learn about in Nearpod lesson 3.8 and 3.9. So at this point, go ahead and go back to your Schoology page, scrolling down either on the upcoming or in week 7, December 8th, Tuesday class materials. You'll notice that there are 2 homework assignments, and I just split them up because they're kind of 2 different ideas. Lesson 3.7 is on average atomic mass. Lesson 3.8 and 3.9 are both about radiation and radioactive or unstable isotopes. So to complete your Nearpod lessons, go ahead and click on homework. I'm going to do Nearpod lesson 3.7 first, right? And if you click on it, a reminder that these are the key ideas you're taking on for the notes, and that's it. Here's the link to your Nearpod lesson. And remember to please type in the code that's linked on this doc down here, and then your full name. And you're only taking notes on these 2 things. When you're done with the Nearpod lesson for 3.7, There's also a document titled Average Atomic Mass Practice for you to practice calculating average atomic mass, right? So if you click on View Documents up top somewhere on your view and then click on Edit, you should be able to open this document titled Average Atomic Mass Practice. Notice that you only need to do questions 1 through 4, and you're also going to need a periodic table to help you out for questions 2 and 3. All right. And just in case, I'm also going to go over the other homework assignments you need to do. Nearpod lesson 3.8 to 3.9. So if you click on that, these two in steps 1 and 2 are your directions for Nearpod lesson 3.8 to 3.9. There's also a series of practice questions on here. So if you click on View Documents up top and then Edit Documents, you should be able to open something called Radioactive Isotopes Homework. Right. So for these questions, sometimes you might not be able to know how to type a number on top and a number on bottom. So I linked a video here to show you how to do that, to type in isotope symbols, as well as ptable.com to help you out with some of the questions. Right. So hopefully that should help you out with this particular homework. And that's pretty much it for today. I also want to recognize that these Nearpod lessons, both 3.7, 3.8 to 3.9, are a bit long. So I will give you some class time on Wednesday tomorrow to finish these up. But if you finish them at home this evening on Tuesday, then tomorrow will just be a shorter day for you. Okay?